Hi, and welcome to lesson 9, part 2. If you remember, in lesson 9, part 1, we did meshing for common research model, half body. It just has the wing and the fuselage, so it's called wing body configuration, and we used a symmetry uh, to capture the half body shape. And we did the solid meshing, surface meshing, and we stopped uh, halfway through, and then we improved the grid quite a lot. But today we are going to do the rest of the improvements, manually moving these edges to the right places and putting the boundary layer in OGrid, using OGrid capability of ICEM CFD. So let's get started. So first thing I want to do is just tell you that when you have the solids blocks with, which we will delete later. If I go to turn off the edges, turn off the pre-mesh and turn on the blocks, I have the blocks that's representing the aircraft, which I have put in these parts called fuselage solids and wing solids, which I will delete later. But as long as they exist, where I was showing you faces, these blocks. So the fluid domain is represented in the red color blocks, and the fuselage is in yellow, and the wing is in blue color blocks. So as long as these blocks exist, the the pre-mesh is going to confuse and project the edges to surfaces, which is why we have some deformities and some problems with the mesh. But we can't do anything to help that at this stage. Once we put the OR grids around the blocks, we can delete the blocks that is representing the aircraft. Okay, so these blue edges representing the internal edges or the fluid zone, we can move them around to the right places, because at the moment they look like very skew. So what I'm going to do is just go to move vertex and manually move them, fix them in Z direction, and manually move them to the right place. You can even use align vertices and align them with the vertices on the wing. But for now, I'll just move them manually, just good enough so that we don't have skew mesh like that. Okay, so they are not, they will have to be aligned in the right Z place. So I'm going to use a set location and fix Z. My reference vertex was the one on the wing, which I've already selected, and now I'm going to align all these vertices to the right Z direction. I missed a couple, so I'm going to do that. Yeah, now I have to move them again in the right Y direction, X and Y, fix them. Okay, so this, 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 right. We can even move the just in Y direction to make it more equal to each other, the blocks. And maybe some movement here as well. Okay, some movement here. and some here as well. Make sure that they're moving in the without getting intersecting each other, So at the moment it looks fine enough for us to generate an O grid, which we'll do now. So first thing I will do is generate the O grid for the wing. So select the parts in the wing, so let's accept that and click apply if it is around the blocks. Yes. Now this is what happened, and we will yeah, we can accept that for now, and then we will go to again select blocks and accept the fuselage solids and click apply, and we will have something that's very small, so we will need to manually rescale it. And to do that, I'm going to go to edit block, modify O grid, rescale O grid, all visible and in this edge direction, and twice click apply, then again click apply until you're happy with the distance. Let's just check if it is okay now. Most of it is okay, and remember that it will be intersecting with the O grid we did for the wing, so it needs to be still a bit more, because the O grid on the wing was quite huge. Click apply again, and one more time. Okay, so we rescale the O grid now to represent the fuselage and to represent the fuselage. Now what we can do is go to delete block and delete the wing solids and fuselage solids. Click accept, and then now we have something that we can work with. So once I deleted, remember, all the edges that was representing the fuselage inside and the wing inside has been removed, and they're in the VORFN. If I click that off on, you will see it is in the VORFN, but we don't need that. And now we just need to link some edges. So what we are going to do is go to link edge, and I would suggest a factor of 1.25, just so that the O grid doesn't go through the surface. Okay, so this one to this one. This edge is not split yet, so we have first I will have to split it by linear splits, and then move them manually. This one. Yeah, can. Okay, and since these edges are now kind of they've broke out of their shape, I'm just going to unsplit them. Okay, so to make things easier, I was going to go to index control and move to just one, yeah, just the one on the surface, just the edges on the surface. So we'll do one by one. So this one to that, this one to this, from this to this. Let's just use a higher edge pointing, so 1.25, this to this. Okay, and then manually move some of these vertices, fix them in Z direction. So that's not going to work. Yeah, this and this. Okay. Yeah, and again link. So a lot of linking of edges. 1.2, 1.3 here I will use just to be sure. Yeah, and even this one I'll use 1.3. Okay. And now let's move on to the next K. So the next block, next edges. So we're doing one by one by moving in the K direction or the Z direction blocks edges. We'll have to link this edge to this edge. Okay. This edge to this edge. Yeah. This one to this one. Yes. This to this. Yes. And this to this. This to this. Now remember that because we rescale the O grid, there will be some problems here. So we'll have to manually, what we can do is go to edges and hide the internal edges, hide the geometries, just to make things a bit more clear for us. And then we're going to link this edge to this, and this edge to this. Now this is the one coming from fuselage, so we'll have to move them in Y and Z direction, but let's just move them in Y for now. Okay, and even here they have swapped their place, and then we can link this edge by a factor of 1 to this edge and this edge to this edge. Okay, so it's just like this. You link all the edges to each other, and then the internal edges, which represents the O grid or the live fluid zone. So this one to this one. Now that was a little bit less than I wanted, so 1.3 again. Yeah, and this one to this one. That was a bit, it's okay, but since on the trailing edge there seems to be some stuff happening, we need to correct that first. So we split this edge. Yeah. Right. Then maybe just move them a bit closer to to the trailing edge. So, Okay, but since we unsplit some edges, we will need to relink them again. So I'm going to link this one to this one, and this one, sorry, the surface edge to the internal edge. Okay. Right, and then these edges by a factor of 1.25. So this is really up to you to decide how much you want to link them. I'm just trying not to make sure that they don't touch the surface of the aircraft, because if they go through the surface, that means that they will the O-grid will be cutting through the surface, and then we'll have negative volume elements. Instead of linking like this, you can even use the spline option and then or linear option and do manually on your own. Just get the shape of the aircraft. See, now some of these internal edges are going through the surface of the aircraft. So that's going to be a problem for us. So what I'm going to do is just manually move them outside using fix X and move in Y and Z direction. So just like this. Oh, here we have to fix Z and move X and Y. Yeah, so now let's put on the surfaces again, solid view, and we'll see that the internal edges are now going outside, which means we have some space for the O-grid, which is good. Okay, so then we do repeat the same thing for all the surfaces, including the wing. Here's some internal edges going through the wing as well, because we haven't linked them. So let me turn off the surfaces again and link first this internal edge to this internal edge, then from this to the this surface edge to this surface edge, and from the surface to the internal. Okay, so now we have that sorted. Right, we can definitely improve this area still by using manual splits for each of the edge. Let's go ahead and put more in K direction, and then we can use the linkage to link this to this and this to this and this to this, this to this. Right, okay, so we can go ahead and put some edge mesh parameters in the O-grid. I'm going to put 22 cells in the boundary with 1.2 ratio, and spacing 2 will be 0.01. The spacing 2 really, the final spacing of the first cell really depends on the Reynolds number and the flow of interest. I'm just putting some number from just randomly. Okay, so even here we can first improve the, the way this is appearing, yeah, like this, and put some in the O grid. Since this O grid seems to be bigger, we can put more cells, maybe 32, and in the ratio of 1.2. and 0.014 apply. Now if we do pre-mesh now, it should improve the overall thing. Yes, it did, except that we still need to update the mesh parameters to resolve everything better. So for example here, if I put instead of 16, if I put 44 and define my spacing 1 and spacing 2 as 0.4 and 0.4, click apply, then I'll have a better resolution for my wing. But this is the general idea of how to go about it. We do need to update the mesh parameters for the edges going outside. So for example, this one is spacing 1 is 2, click, sorry, spacing, we have to see the direction of the edge. So this edge is going up, so reset and edges. Since this edge is going up, I will use spacing 1 as 1 and ratio 1 as 1.1. Click apply, and here is fine. Click apply, here it's fine as well. So let's just pre-mesh. Now this is what we have. We have like I said, we can improve the mesh parameters for the boundary and move the edges to the right places. But this is the general idea of how to use blocked meshing parameters, and we don't recommend these. For example, the cell spacing here is really small, and the cell spacing here is really big, so that's not recommended. We can use smaller spacings, so play around with the mesh spacing parameters to improve the overall the mesh quality. But let's just double the pre-mesh and then have a look. Yeah, and this is what the mesh looks like now. We see the boundary layer, and we can use scan plans to view if the mesh is okay in the volume zone. So for example here we have, now if we turn off the edges, go edges and off, and make this a solid view, we can see kind of how it goes through the volume field. Turn the pre-mesh off, and like I said, we need to play with the spacings to make it a better mesh, but this is the general idea. Well, thanks.